Now in the last video we introduced how we're going to have questions dealing with the discriminant, and I'm going to use a very similar example here, y equals 3x squared plus kx plus 3, and this time really I've made this sure that the question is like right there and plain and open for us. For what values of k does this have at least one real solution? Okay, so in all of these types of problems we're going to be using the discriminant. Now because we want at least one real solution, it must be greater than or equal to 0. Okay, at least one. If we were just looking for, if it said for what values of k does this have one solution, we would set it equal to 0. But because we want at least one, we can have two as well. So we want greater than or equal to 0. So in this case we have a is 3, b is k, and c is 3. And then we just substitute the values in. So we have b squared, so k squared, take away 4 times 3 times 3 is greater than or equal to 0. Now 4 times 3 times 3 is 36. So this is k squared minus 36 is greater than or equal to 0. Now this is a quadratic inequality where the left-hand side can be factorised. So using the difference of two squares. So this is k minus, not 36, just 6. K minus 6, k plus 6 is greater than or equal to 0. So because this is, there is a positive coefficient of the k squared, we're now looking at a parabola that looks like this. Okay, it's a positive parabola. This is now the k-axis, okay, not the x-axis, the k-axis, where the parabola is cutting through minus 6 and 6. And we're asked, where is the parabola above y equals 0? Okay, where is it above the k-axis? And it's above the k-axis here and here. So k is less than or equal to minus 6, and k is greater than or equal to 6. So now you can see that the quadratic inequality bit comes in, and we're solving the quadratic inequality once we've substituted into the discriminant. Okay? And this is how it is linking together. This is the skill that we've learned in the previous videos, and the only difference here is that we are now substituting something of these numbers and letters into the discriminant, okay, and creating the inequality that they're looking for. Okay, so we're going to keep going with this, and we're going to keep on looking at some more tricky examples.